So, guys, last week we did ionic bonding. This week, covalent bonding. RF, time to go. Did I ask you to talk? Cool. Guys, so very, very important. I taught my eights this an hour ago. If you go the worst of my eights, we do not have hope in life. So, Jeremy, no one cares. Pay attention. So, guys, covalent bonding. Two things to remember. But guys, what was ionic bonding between metal, non-metal? Cool. Covalent bonding is between two non-metals. Cool. Guys, on your periodic table, if I draw a periodic table. Thank you, Jeremy. It's a covalent bond. Cool.
Yeah.
You saying your pen was, right?
Yes.
Cool. Was that necessary?
Yeah. No.
Make up your mind.
No. Yes.
Bruh. Guys, were your metals on your periodic table? Huh? Left plus middle, but no one cares about the middle, so fine. Zoom people, turn your cameras on if they're not on. Metals. Aish, where are the non-metals? Perfect. RF, stop talking. Genuine. Cool. So what I'm trying to say is we're no longer forming ions. We did the 2,6 electron configuration we care about. We are not doing forming ions, but in gaining 2 electrons and going O2 minus. None of that weird stuff. But that brings me to my next point. It is sharing electrons. To achieve a full outer shell. Chris, stop talking. Time to talk? Okay. So, again, just like ionic bonding, everything with the full outer shell. Hence, covalent bonding is the same thing. Okay. Cool. Guys, there's no other way to do it except being good. Which means two things. Either you're really, really good at intuitively finding it out, or you've memorized like all of them. I was probably the second part because intuitive takes a crap ton of time. Let's have a look. Jeremy,
Yeah.
what is this? Jeremy, is hydrogen a metal or non-metal? Huh? Non-metal. Guys, Jeremy's smart. He remembers hydrogen even because it's on the left, it's still a non-metal. Brass, yes. Huh? Okay. Water. Jeremy, how many hydrogen, how many oxygen? Cool. I will tell you, hydrogen has 1 proton, oxygen has 8 protons. Can everyone find the electron configuration of both? Ari, that was you, that's not subtle. Whatever you're doing, don't. Raj, you're here.
It's not.
Huh? Write it down, very important. I know. Chris, do the work. So, I agree. Aryan, this is just 1 electron, do you agree? Thank you. What about for oxygen? 2,6. Guys, my inner shells are full. I am doing nothing with my inner shells. They are already full. Hence, I don't even get to draw my inner shells. If you guys remember, I did this with you guys last year. Same thing I've taught you guys last year. So, guys, 2 hydrogens, 1 oxygen. Just like, because we feel like, what do you reckon we should put in the middle? The hydrogen or the oxygen? Right, there's 2 around it. That's going to work pretty well, right? Oxygen here, hydrogen here, hydrogen here. How many electrons in the outer shell of oxygen? 6, we just said, no? Let me arrange them. Just leave them there, I'll pick them up after. Guys, The same thing we can do is this. We are sharing electrons. Let me assume one pair of shared electrons. The hydrogen also donates one. Guys, how many electrons, Steven, around oxygen now? Are we happy with 8? How many around the hydrogen, Steven? Happy? How many around the other hydrogen? Happy? Hence, we're all happy. Hence, the diagram for this is called the dot and cross diagram of water. If you were to convert this to something called a Lewis diagram, it would look like this. What have I drawn? A single line means one shared pair of electrons. Can someone tell me one shared pair means how many electrons? Cool. Remember that. 2 lines means 2 shared pairs. 3 lines means 3 shared pairs and so on. That is how you do covalent bonding. By the way, these are your covalent bonds. Cool. What these things are called here that I drew on the top. Any know the name of these? Rod, any clue? These that aren't participating in the bond. What are they called? They are not in the bond. Hence, what would you name it intuitively? Non-bonding electrons or lone pair of electrons. Okay. Hello, Jeremy. Are you teaching? Why do you call me sir? I did that though. It says not learning the teacher's name. Mrs. Yeah, Mrs. is exactly what it said. Okay, guys. Okay, let's do a couple more. Anyone know what oxygen gas is? O2, not O. We're gonna learn why. That's hydrogen peroxide. Does he go to your school, Krish?
Yeah.
Actually?
That's why I was the lowest. Yeah, you did like the support.
Guys, oxygen, 8 protons. You can calculate, are we, Ari?
Yes.
Exactly. That means you're in your phone.
It's not.
Rod, electron configuration. Perfect. Guys, 6 electrons. Pay attention, very important. Let's start by assuming one pair of shared electrons, okay? I'm going to start by assuming one pair of shared electrons. Krish, please stop talking. Arif, stop talking. Guys, please don't make this mistake. My year 8s made this mistake. My year 8s would be like, oh, why do you not draw 8? It's only outer shell, exactly. Ayush, how many around here? Are we happy? How many do we want? So, instead of sharing just one pair, Ayush, what's the next step we could do? Add another pair. So let's do this, and we can share here. 1, 2, 3, 4, 5, 6. Please remember, there should only be 6 blue crosses. Oxygen only has 6 in its outer shell. I can just add as many as I want. Cool. 1, 2, 3, 4, 5, 6. Ayush, now tell me how many around here. Happy? How many around here, Ayush? Happy? Hence, our Lewis structure of this are of you talking. I know you are. That's nothing new. Okay, looks like this. And again, if you want to be fancy, you can do dot 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 dot. You can do dot 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 dot. Okay. Guys, 2 lines means 2 pairs of shared electrons. Hence why we have 4, if you look at an actual diagram. Thank you, Ned, for toning down your volume when you were speaking. Hello, Arif. Arif, give me another covalent compound. Means 2 non-metals combined.
That's like chlorine.
With what?
Cobalt.
Cobalt is a metal.
Think about it.
No. Chlorine and fluorine can't really bond well. Okay, cool. Let's do that one. Let's do hydrochloric acid.
Yeah, you should try to
Guys,
Sam.
acids are not poison. Hey,
You should try to drink it, Sam. This is really good.
guys, any acid you drink at school will generally okay. It'll be 0.1 molar concentration. You'll probably get away with it. That does not mean do it. Okay, do not drink acid from school.
You're nice shit. Oh,
Mind the language.
I got addicted to acid at a young age.
You don't. We already know the R of. Guys, find the electron configurations, and according to my method, start by assuming 1 pair of shared electrons and draw both the Lewis structure and the dot structure. It's so easy, I promise. I already saw you should get in a minute. I've gone try. Find the electron configurations and do exactly what I did. Ross, are you gonna do it or not? No?
I'll do it.
After I do it, yes.
Wait, what's chlorine?
I told you 17 protons.
that's just empirical acid.
I got it.
Once this head.
Just raise how many fingers of shared electrons. Don't show everyone else. Of the shared electron pairs. Matt, do you mean that many electrons? So how many pairs? Bro just said it. You are correct. Stephen, you know this because I told you this last time. Sam, come on. Guys, we are not making ion. Why on earth do you hate pot? We are just sharing electrons. Guys, fluorine 287. That is 1. Again, I only draw the outer shell of chlorine. Everything else is full. I don't care about anything else. So, chlorine 7. 1, 2, 3, 4, 5, 6, 7. Look at this. Hydrogen just has 1. Ayush, how many around here? Are we happy? How many around the hydrogen, Ayush? Are we happy?
Yes.
1 and 2. Are of which sharing electrons.
Oh, is that it?
That's what the whole point of this thing was. Cool. That is hydrochloric acid. Very, very basic. Okay. If I were to write Lewis structure, it'd be this, and then I'd draw Cl. Depressing. Guys, Arif, please try this yourself. Krish, I'm expecting an answer. Ammonia is NH3. I'll even tell you. Nitrogen is 7 protons. Hydrogen, I don't have to tell you. Draw the Sam, please. Hydrogen is 1. Find the electron configuration. Use the outer shells only to see how many sharing. Draw the things like I drew, like this.
Oh, what? Wait, what about the anonymia? Like, what is that?
Ammonia is the thing that's what you're supposed to draw.
Oh, what's
Hydrogen.
But there's 3 hydrogens, so you gotta think.
Where to put them? What good you. Girls, any girls pay attention? I think you guys are. Ross, I think so, yeah. Boys, try. Steven, you got this. Paying attention. Was that my question?
Wait, I am looking.
Guys, if you're wondering, let me give you a hint. Arian, do you have an answer? Sorry.
I have an answer.
Guys, okay, guys, there are 3 hydrogens in ammonia and not one.
Oh,
Krish, there's not one. Guys, hey, fun fact, you cannot draw this.
I drew it.
Boys, why are you two laughing? That's exactly what you two did.
I didn't draw numbers.
You arguably made it worse than expected by just drawing one.
I fixed it though.
Krish, draw all 3 hydrogens.
You learn from your mistakes.
That is perfect.
What?
No, don't let this kid look. Steven, you got it for sure. Ross, you're not going to understand it.
Let's see it.
Girls, anyone have an answer? Vivian? Girls, anyone?
Look at the board.
That's right, worth asking you. Is it worth asking you? Definitely not, yeah. What's your question? So, this is what's up. Guys, nitrogen. 2,5. Just one. Guys, okay. This is where it's a little bit like practice based. I'm just going to put the nitrogen in the middle and do my H around it. Why? It looks neater that way and it's probably going to be more correct. One there, one there, one there. Hydrogen only has one. Ayush, how many around here? Happy? Intelligent kid, how many around the hydrogens? Happy?
That makes no sense. It does because there's 3
Guys, that is electron configuration for these. Guys, voice up talk. Steven, one more, and then we move on to properties and stuff. No, two more. I can give you notes if you want. Guys, okay. Jeremy, I don't want to hear a word until you do both these questions. Sam, cut draw.
What is the question?
What do you reckon the question would be?
For the diagram.
That's what we need the last 30 minutes, probably.
Oh, I think.
Guys, for these two, I've given you all the information. Ozone is O3. Ethene is C2H4. Hydrogen, we know only has 1 proton anyway. If anyone can get both of these, I'll be so impressed. Ozone, I probably would have struggled with. I know.
I think.
Alright, can you just do your work?
So,
Alright, please try.
oh,
Ross, do you think you have an answer?
what is that?
I'll explain Lewis when I do these. In fact, you can forget Lewis if you want. As long as you can do dot and cross like I do, that's amazing.
So you can just forget. What's that number that you wrote next to H?
That's amazing.
That you wrote next to H?
H4. Guys, I applaud my handwriting apparently bad.
What's one difference?
That's you to think of.
What's that again?
Carbon.
Third
Not quite, no.
Straight line.
Guys, important. I give you guys 3 minutes. If anyone gets any, I'll be so impressed. Ethene is arguably easier. Ozone is hard.
I think I got it.
I can't even read that.
Am I close?
I think so.
Is it?
Yeah. Yes, that's the hair.
No, very close. Hey, wait, hold on. Back in the clock. Can you send me a book?
Oh, because maybe it's so smart.
This
No, I can take credit.
The ozone is the thing.
Oh, but that's just a triple box, isn't it? It's just triple bond. It's just triple bond.
Ozone, I'm just telling you, ozone. Guys,
Like the three bonds.
Jeremy, one of those, you drew 3 different ones, one of them stretched.
This one, like the one I drew
Oh my
line.
word. Aaron, you're close but not it.
Just the one
Irish,
I drew the
guys,
line.
hey, Irish, tell me, how many bonds do you have in ozone? Yeah.
1, 2,
3?
Sorry.
It's 3. So, guys, this is what's up. Guys, 2,4. Boys, alright, stop talking. C and C. Guys, pay attention. If you start with one pair, for example, one here, here, here and here, and the same thing here. If you just do this, and then like, for example, you move them together. Aish, how many around here? Be very careful. 7. That is not it. Hence, Aaron, I'm doing it in a second. Hence, we have to share 2 pairs, as you both did. 2 pairs would mean dot dot, and then simply Arif, how many around here? How many electrons? 4 here. How many total? 8. Are we happy? We want 8. Guys, 8 here, 2 here, 2 here, 2 here, 2 here. Hence, boys,
I think it might be this week.
hence you draw it like this. That is ethene. Ozone is the crazy one.
Oh, then it's this one.
Jeremy, can you stop talking now? So, right, I think you got it. O. Can someone tell me how many electrons outer shell of ozone? Or oxygen, sorry. 2,6. Guys, okay. This is how it goes.
Yes, this one.
It's like this, Stephen, here. Guys, okay, have a look. How many around here? Are we happy? How many around here? Guys, tricky thing. Very, very tricky. There's here, but the weirdest thing is this oxygen will not share any of its electrons. Because if it does, you start making double bonds and the middle oxygen gets overloaded. Hence, I don't want to hear it. It looks like this. That is ozone. See, guys, I told you ozone. I struggle in year 12 with ozone. See, it looks exactly like that. Yes, that is correct. I did it in year 8 have done it. Yeah, it did probably better. No, yeah, you guys, no one got this one except 2 people in this class. But you definitely did this in year 10, 11. 100%.
Okay, so year 10. Oh, wait.
Guys, we have.
So, do you get ozone in year 10 or ozone in year 8?
Year 11 when I saw ozone for the first time.
But why does it all have like some?
Guys, we are now going to talk about properties. Okay? So, it turns out covalent stuff. Boys, cut the chalk. Covalent can be split into 2 main things. You have covalent. All right, I don't want to hear your voice for the rest of the lesson. Unless you have a question which you can ask. So, Chris, you two actually now. Sam, you two. 2 things. Covalent molecular or covalent network. If you have a question, boys, feel free to ask the question. Okay. Chris, questions? Let me finish writing what I'm saying. So, covalent network basically means covalent bonds, but they extend to like pretty much, they form like really like intricate like lattices.
Also bonds that extend.
It's basically covalent bonds forming really, really large structures. Question, Chris? Because you guys talk more than everyone, Pross not listening, the girls don't distract me anymore. You 3 and Jeremy. No one else distracts me. Those boys learn their lesson, don't talk anymore. Who else is it? Who?
Not saying anything.
Oh, Aryan is included in it. He's correct. Huh?
What?
Intelligent, right? Who's DJ then? After Daniel and Jimmy pulled the thing last year,
Oh.
the respect has been lost. Well, I generally do not care right now. No, Crude did. No, you might have actually got more than it. So, that's covalent network. Forms large molecules. Daniel, what is covalent molecular then? Arav, get up. Sorry, Daniel, continue. Sorry? Agree. So, what he's trying to say is, boys, it's like small stuff. Pretty much correct. Cool. That's the main thing. Can anyone give me any example of covalent molecule? Ozone is covalent molecule. Small stuff. Anything which is like 2 or... Okay, let me tell you. Network is pretty much like diamond. Diamond is like C, like billions. Small stuff is like discrete stuff you can find.
Everyone had a teeth.
Guys, for example, your molecular are like carbon monoxide, water, and so on. Very, very important. The distinction is super, super important. It is important because properties of each are very, very different. For example, oxygen gas. Is oxygen a gas at room temperature? Diamond is not a gas. Both are still covalent. That's the main distinction. Chris, you'll move next. So, guys, this is ionic compound, lattice shape. Anyone know what this is? Ice. Wait, hold. Why on earth are we doing ionic properties all of a sudden? Okay, guys, for those who don't remember, ionic was metal and non-metal bonded to each other. Properties. Main ones, boys. Sam, don't talk again. Christian too. Both. Technically, ionic compounds have really, really high melting points, boiling points. It is because positive and negative ions in your ionic lattice are very, very strongly bonded to each other. Technically, covalent networks also have really, really high melting points. For example, when's the last time you saw diamond melt? You're not melting diamond in Minecraft. Cool. That's property one. So, see you in here. Property two. Ionic compounds are soluble in water. That basically means, girls, lower the volume. That means dissolve. Cool. What it means is this. If I have Cl- and Na+, in water, it breaks apart. So that you have Na+ by itself, and then you have Cl- by itself. Cool, dissociation. Quite important. Is very, very important in human body though. Can someone tell me, when I dissolve it in water or when it's melted, why does it conduct, boys? Why does it conduct electricity? You are correct. We don't know that word though. Electrolyte. Guys, tell me, are these charged particles? If they get melted or in solution, are they mobile? Why not? I told you when you melt it, these things become mobile, or when you dissolve it in water. Hence, in fact, remember this. Girls, cut the talk. If you want to talk, do it really quietly. Both things very, very important. Arian, if it by itself, it is also charged. It won't conduct though. Why? Because you need charge to move to be able to conduct electricity. That's why it's both mobile as well as charged particles. That is why only when you dissolve something, an ionic substance in water, when it splits, or when you melt. Huh?
Yes.
Probably the rate you guys are going. Covalent compounds of molecular stuff. Girls, cut the talk. Of molecular stuff, for example, your oxygens and things. Oxygen is a gas at room temperature, which means it's already melted and already like evaporated. Which means its melting point, boiling point must be really, really low. The table shows some of the melting point, boiling points. Why? Again, this you do not really need to remember. Chris, can you not sit still? Guys, what's the difference? This is so important. Intra versus inter.
Inside a molecule.
This means inside. For example, all your ionic bondings and everything, covalent is all this. And so on. Why? This is the reason. Yo, that's just keep your hands to yourself. People and their tendencies in life these days. So, ionic covalent. Pardon?
Yeah.
I don't get why everyone. Nah, I shouldn't say that. So, intra, Beth, if you have a molecule here, or if you have two things here, the force between the two is your intra. Within, intra means within. Inter, though, means between. Water, covalent is intra, but water to water. For example, if you have water here and water also here, there's a force here, which is inter, but there's a force within the water, which is intra. When you melt stuff up, especially covalent stuff, you only affect intermolecular forces. When you melt water, you don't get oxygen and get hydrogen, do you? You just get in its different states. So melting, boiling, everything affects this. I have not taught you any intermolecular forces, nor will I ever. Couldn't teach you in year 10 or 11, that's fine. Yeah, 10, he teaches all science. I don't teach, no one teaches anything in year 9 or 10 or above, that's not him. What's her name? Aria, Lulu's sister. She's really, really good. Like really, really good at lit and English. I'm not sure about English. She topped the state in English and lit, I think. So I think she's really, really good at both. Something I'm wondering too. Where on earth did Parn go? But me. People are in depression after teaching you guys. So, guys, again, melting, boiling affects inter between things. You do not break up water to get hydrogen. Okay. The point is, covalent compounds have low melting boiling points. Why? Because their intermolecular forces are weak. This is intermolecular. That is why a lot of them already are. Guys, a fancy word, volatile means readily evaporates. Guys, another very, very important thing, they tend to be insoluble in water. There are exceptions. Tetrachloromethane stuff will. You don't have to know why.
Why?
Again, in intermolecular forces, it forms really, really strong dispersion forces. No conduct electricity. Arian, why not? No charge mobile charge particles. Cool. 99.9. Oh, really? But thank you. So,
Not really.
is it 0.95?
So that's like
My sister got 0.95, that's why.
Does your sister brag to you?
She does still.
They definitely got my smell.
So, guys,
Oh yeah, I
It's
think
like in the India one.
boys, okay. Worry about your ATAR over other people, otherwise you guys will be at like 88s and stuff, okay?
88.
Chris, at this rate, you're not here at 9.95.
Yes.
What's there to be happy about? Okay, guys, we're going to the opposite ones. Jeremy, caring about your life and getting higher does not make you a sweat.
And what does?
Huh?
And what does?
Are you gonna sweat then?
But
Yeah, and get a high ATO, or do you want a low ATO?
I want to get a higher income.
when I get 45,
About 20.
Cool, let me know what you do in the future then.
Dad, do you have anyone about one?
Huh?
I'm gonna get
What, 90 something?
past audit.
I know you had this mentor.
So, guys,
Did you write a sentence in that?
for 4 years and then plus 1. Giant. Krish, I don't care right now. Guys, your giant covalent networks. Guys, I did say it's the same as extending, yes.
What sentence?
These are your main ones. Look at their melting points. Very, very high. They have melting points like kind of like ionic substances.
Especially like.
Don't memorize the values, know the ones. In fact, only know this one, I'll be okay. Carbon in its tetrahedral form. Christian, stop talking. Frost, cut it. Frost, what's your last name? Huh? Tell me your actual last name. I was going to know.
Just take the rolls.
Okay, easy. I know who to talk to Kunj about that. Rob, I've had enough of you now at this point. Cool? Yes, he said.
If I say no, is that going to change your?
Yeah, you can be like, oh no, I'll pay attention from now. But
I'll pay attention.
let's see if that even lasts for 5 minutes. So, diamond, tetrahedral structure.
Dad, why is English longer than science?
Arian, do you want to be part of that Prahas group as well? Thank you. I don't teach English. I got no clue. Tetrahedral. For those that don't know what tetrahedron is, it's a triangular pyramid. Each carbon bonded to 4 others. This carbons are arranged in a tetrahedral structure.
Pyramid.
Each carbon is bonded to 4 others. Have a look. This one, 1, 2, 3, 4, and so on. Again, remember, and just like are you on your phone, Ross? Okay. Just as like a general rule of thumb, just a general rule of thumb, Brad, give me a sec. These are usually much stronger than these. Hence, in your diagram, that's why they call these strong covalent bonds. Raj, yes?
Why did they arrange it?
Okay, good question. Carbon, Raj, 6 protons. Give me electron configuration. Hence, how many carbon, non-metal, right? 1, 2, 3, 4. How many covalent bonds can it form? With what other carbons? Hence why. It's all spaced evenly apart. So the angles are all the same.
Why is carbon so much more rarer? Why is carbon so much more rarer?
We get it? Cool. So, diamond, obviously. You said you'd pay attention. So, just like it. Very strong, can't break easily. Again, due to the strong covalent bonds. Again, high melting point. Don't need to remember it. Can someone, Ayush, give me a reason why can't diamond conduct electricity? Are you Ayush? Go for it.
No.
Well, I mean, the diamond. No.
Yes, I know.
That doesn't give me a specific reason.
On mobile, sir.
No, that's synonyms. Steven, No free electrons because all of them are bonded.
Because it's not vibrating.
No, do not say that.
That's it.
Wait, can't conduct.
No, I said that was the money.
What does that mean?
Huh?
What does that mean?
Tough, very tough. Again, diamond is bonded strongly, so it can't vibrate, so it can't transfer heat energy very well. Silicon dioxide also looks like this. This is silicon. This is oxygen, oxygen, oxygen. It removes moisture. It's a desiccant. No, it depends. You often find like silicone gel in like shoe compartments when you buy shoes. It's because it removes oxygen from the air, so your shoes don't get like behind. The shoe box off another. Guys, graphite, another one. Go ahead. Exactly. Agreed. So, boys, cut the talk. It is not the same as isotope. Isotope means you're adjusting the number of neutrons. Here, you are not. The only thing you're changing here is how the carbons are bonded to each other. Guys, structure. Graphite looks like sheets. Each sheet is called graphene. Guys, these are intermolecular though. Remember, intermolecular means between molecules, between the sheets. These, however, are intramolecular. Same element, different structure. Guys, I'll do metallic bonding next week because we don't have time this week. But sit down for one bit. One more thing. Guys, very important distinction. Graphite can conduct electricity. There is. Guys, everyone's quiet. I'm not thinking. Girls, we said we're going. What? I don't know. Why? What is it? Bro, what? Screw that. No one cares. So, are you gonna be here next week?
Maybe.
Okay.
Yes, I will. What's the country? Oh,
It'll be so quiet then without you two.
Sir, how do you do that? But yeah, go to bed.
So, guys, one thing I'll let you guys go. Guys, diamond cannot conduct all electrons are bonded. Graphite has one free electron per ring that can conduct. Carrying charge. Hence it can conduct. You guys can go. If you're not going for the long weekend, have a good long weekend. I'll see you the week after.